Hi, this is Dr. Bixby. Welcome to the first day of General Chemistry Lab. We're going to teach you a few things about Excel, some functions that you may or may not know. It will really help you keep track of your data, fix your mistakes, save you some time on your calculations. Anything that you do in Excel you can print out and put into your lab notebook, but it's always good to have the actual file that you can go back and look at your original data. Over here, I have a list of all the things I'm going to cover in this video, and as we go along, I will try to timestamp this so we know where things are in the video. As you can see, the first thing I want to talk about is moving data, or moving anything from one cell to another. The obvious way to do this is to click on a cell and to cut or to copy, and then move it to another cell and hit paste. Right? That seems pretty obvious. I'm going to Control Z that so that I can put it back where it was. But if you have whole swaths of data and cutting and pasting isn't necessarily super efficient, you can select your whole bunch of data, whatever you want to move, and you'll notice my cursor here is a plus sign, but if I move to the edge of my selection, it turns into a hand. And once you have the hand, you can click and hold it and move that set of data or information to wherever you'd like to move it. So this comes in handy if you're doing some extensive calculations and you forgot to add a trial and you need to move 2 columns over, right, to make an extra column there. That's a good way to do that, just for organization's sake, without breaking up your references in your calculations, which we'll talk about in a minute. The next thing I want to talk about, so now that you know how to move data around, the next thing I want to talk about is the name, date, and your partner, any pertinent details that you need to have for future reference about what's going on, or if we ever ask you to turn in an Excel spreadsheet, you need to have in the cell A1, you need to have your name, so there's my name, Dr. Bixby, and the date, and it is 8/28/17. And you can put your partner. Right now I don't have a partner, but you could also put anything else about the experiment that you think is important. So when you took data, when you actually calculated things, did you recalculate, anything like that. This is an Excel tutorial video, and so that's what I'm going to put there for 2017. Alright, the next thing I'd like to talk about is scientific notation, decimal places, and general good practices for upkeep of an Excel spreadsheet. So the first thing you'll notice is that I have, first thing I will call your attention to is that I have labels for every column, every bit of data that I have here. So what this label is, the brackets mean concentration of, and so I've got concentration of methylene blue. You can see the whole word spelled out there, methylene blue. And then there's a comma and there's this capital M, and that doesn't stand for methylene blue, that stands for the units of concentration, which is molarity. And so I'm including the units because there's a lot of different ways that you can do concentrations. You can do a concentration in parts per million. You can do a concentration in molality, okay? But molarity is what was used here, and so I want to make sure that I indicate that so that later, 3 years from now, I know what units these were kept in. Okay, so I've got 4 solutions here of different concentrations that I prepared, so I know exactly what their concentrations are. And I took absorbance measurements in a UV-Vis spectrometer, and I took 4 trials of each solution. This data here, okay, you got all these zeros. I'm sure in high school you learned something about scientific notation that is much more efficient for representing these values. And so I'm going to highlight all of those values. I'm going to go up here to number line. You can choose the formatting for this. And right here on this list, you got a fraction, a percentage, etc. but you could also have scientific notation. So I'm going to hit scientific notation, and it's going to give me scientific notation. Generally, it does give you 2 decimal places there after the decimal. You can change how many decimal places it gives you by using these buttons if you have them. That makes it super easy, but you can also format the cells. So if I go to format the cells, that's going to be on the main toolbar for Excel. It should pop up a window, and I have all of the options for formatting those cells. I have this also, this scientific choice in that menu, and text alignment. How many decimal places do I want? Do I want 3 decimal places, 4 decimal places, 1 decimal place? I'm going to leave it at 2. You can align the text so that it is, at an angle if you like. I'm going to make sure that this is in 0 degrees. Okay, you can change the font that's there. You can do superscript, strike through, subscript, outline, any kind of text formatting that you would do in Word or anything like that. You can put a border around the cell here. You can fill it with a specific color if you'd like. All the options that you need are in that menu, and so if you don't have any of these fancy buttons up here at the top, you can always find this under Format Cells. Format Cells. Okay. You'll notice that I don't have the same number of decimal places in any of these either. If you type in a number that was 0.300, okay, and hit enter, that cell seems to be formatted for 4 decimal places. Let's see if I can find another place. 0.300. Okay, it got rid of the trailing zeros for me. Trailing zeros are significant. So if you're reading an instrument and it gives you 2 trailing zeros, you need to record all those zeros. And so maybe you've actually typed that in, but Excel has now eliminated those zeros because it doesn't think that they are significant. So if you want to change that, okay, again, you can go back to Format Cells, tell it exactly how many decimal places you'd like, or you can include them that way using the button at the top. And so Excel did that exact thing. Each one of these numbers should have 4 decimal places because that's how many significant figures my instrument had. But you'll notice that some of them have 3 because 0 was the last digit. That was not, it was typed in, but Excel eliminated it. So I'm going to change all of my formatting here so I have 4 zeros. Whoops, 5, 4, there you go, in every single one of those. And I'm just going to do that down here as well to make sure that I know that I've done it. Okay. So column labels, make sure you understand what's happening and you're not just quick trying to do math because 3 years later you're not going to remember what you've done. Okay. So our goal is to take these 4 trials, do an average and a standard deviation so that we can plot the absorbance value on the y-axis and the concentration on the x-axis. And that's going to give us a calibration curve so that we can determine what the concentrations of our unknown samples are. So we need to do an average and a standard deviation. These are just the simple functions, simplest functions that you will have to use. There's a lot of mathematical functions, but we can definitely go through those as we go along. But here I'm going to, again, make sure that I label the columns that I've got, average and standard deviation. Okay, I'm going to move those over, okay, so that they are next to my table. And I'm going to average this. To do any math in Excel, you start the equation with an equals, okay? So the cell will equal whatever your math function is. In this case, I want to use average, so I'm going to start typing average. And the function is itself the whole word average. And you can see it's trying to autofill, so that's great. I'm going to do that. Now it gives you parentheses, and you've got number 1, number 2, number 3, and you can type in specific numbers. Okay, so I can type in D13, comma, E13, right? You can type those all in if you like. You can also click on that cell and then put a comma, and then click on this cell and put a comma, and that's great, especially if you have data in various locations and it's not all next to each other. But you can also just click and hold and then drag that across to select the whole 4. Okay, and now you'll see that there's a semicolon in the middle here that says average the cells D13 through G13, and then you hit enter. Excellent. Now here's where Excel is going to save you a lot of time. I'm going to do the same thing to the next 4 in the next row, and I'm going to do the same thing to the next 4 in the next row, and etc. And so instead of retyping average and selecting cells, what I can do is select the function cell that I've already made, and you'll notice that my cursor is a white plus, and if I go to the corner where there's this little box over here, it'll turn to a black plus, and if I click and hold and drag that down, okay, you see what my cursor did, and then let that go, it copies the formula down. And what I want you to notice here is that this was highlighting D13 through G13. If I click up here in the text, it'll show me which boxes are selected. Okay. Now if I go to the next cell down, I'm in D14 to G14. Okay. So not only did it copy the formula down, but it also moved the reference cells down as well. Okay. So just keep that in mind. Standard deviation is a similar procedure here. We're going to say equals STDEV. Okay, that's all you really need, STDEV right there. And then again, select the numbers that you want to take the standard deviation of. Do not select the average, right? It will give you a standard deviation of that average, but you want to select the actual data points and not the average box. Okay, so I'm going to hit that. I'm going to copy this down as well. Okay, and you'll notice Excel gives you all of the decimal places ever, so you want to make sure that this is a reasonable number of decimal places, and because my average and all of my original measurements were 4 decimal places, I'm going to keep this also at 4 decimal places. Alright, so that was average and standard deviation. Let's make a scatter plot of our data. So I want to plot the concentration of my solutions versus my average. So I'm going to hit Command, okay, or I'm on a Mac, so I'm hitting Command to select those 2 columns of data, and then I'm going to go to Charts up here in the menu bar, and I'm going to select a scatter chart, and I'm going to do a marked scatter chart. And there, it's given me a marked scatter chart. That's amazing. Okay. I will point out, okay, that you'll notice the scale here goes from 0 to about 1.2. That looks like the average value here, the average absorbance value. That is what I want to be on the y-axis, and I want concentration on the x-axis. I'm going to make this a little bigger here so we can see our numbers. Okay, we'll change some of these things so we can see everything. A lot of times, if your data happens to be have what you want on the y-axis first in a column before what you want on the x-axis, it will plot it backwards. And so you just need to be careful about what's being plotted on what axis, and you can change that. Okay, here I'm basically left clicking or control clicking, and I'm going to go to select data, and that series of data that I have just selected here, now I can choose what I want on the x value, I can choose what I want on the y values. So I could change this to H, right, if I wanted to, and this as well, and then this to C, okay, to get back to the other way of x and y. but I don't need to do that right now. This menu is also where you would add a second data set later if you needed to. Okay, we'll show you how to do that. Over here we have a key that'll tell you if you have multiple data sets. It'll tell you, oh, the blue is the methylene blue concentrations and the red is the Congo red concentrations, and so you can plot them all on the same chart and have a key here for in the legend for what data set is what. You can label them. Right now we only have one data set, so I'm just going to delete this this little box, and that kind of expands the graph a little bit. You do want to make sure that when you make a graph, your data is filling the whole space that is available. You don't want to have all your data up here in the corner, and so you can change your axes, the limits on your axes. So if your data is only from 6 times 10 to the 5th up to 8 times 10 to the minus 5th, then you can change that scale so that this is where 0 would be, and blow that data up so we can actually see what it looks like. You also want to make sure that you have axis titles, again, so that you have thought about what is on each axis, and other people who are reading your plots know what is on each axis. So in this case, I have concentration of methylene blue. And again, I'm going to put my units in here. You should always make sure you've got your units there. I'm going to add my vertical axis label, and then this is going to be average concentration. Oh, I double clicked on it, so now it's going to try to open the formatting window. Okay, I'm going to skip this, cancel. Okay. Okay, so this is absorbance, which is unitless, so I don't have to worry about this. I could say average absorbance because it is an average. Okay, and you can put a chart title on there too, especially if you are putting this plot into a lab report. You should always have a chart title. So here I'm going to say it's a standard curve for methylene blue. Okay. Because these are averages, I want to make sure that I represent that distribution of points. So I need to add to my points some error bars. The error bars will be the height of the standard deviation, so we're going to have to reference that standard deviation. So here again, I've right-clicked on this and I'm going to, let's see, format my data series. Okay. However you get to this menu, okay, I can change an axis, okay. I can change what the markers look like. So right now they're blue squares, but I could change that to be a different color. So I could change that to be red squares if I want, or I could change that so that to make sure that it has a black outline. Okay, however I want to do that, I can change the shape. Okay, that if I want. So if I change it to a circle, okay, you can do whatever you'd like here to format that. But this is what I'm interested in right now, these error bars. Okay, so if we want our standard deviation, this average is for absorbance, and the standard deviation will also be in absorbance units. So we're looking for that y-axis error bar. So it's not going to be this x-axis error bar. You want a y-axis error bar. So you want to make sure you select the y-axis error bar. You want to select that there are both the upper limit and the lower limit, not just one or the other. Okay, and then you have all these choices. Fixed value, 10. No, that's unreasonable. That doesn't mean anything, right? A percentage also doesn't mean anything unless you've only got one set of measurements and you know that your instrument is plus or minus 5%. Okay. Standard deviation, one standard deviation or more. I'm actually not sure how it calculates this, but it's not referencing your actual data, so you don't want to use that either. What you really want to use here is custom. So you want to specify what those error bars are going to look like. So when this custom error bars window pops up, you can delete what is in that box, and you can select this range, okay? All four of these things. And what that means is standard deviation is going to be the average plus or minus, right? So this is the plus value, and the minus is the exact same value. So you're going to highlight again the standard deviation set, and then you're going to hit OK, and it will redo that for us. Okay, now this custom data set is too good. There's not enough error here to see our error bars. So let me just change our marker style so maybe we can see it. Yes, something like that. Okay. Does that help? Not really. If we had more error, more deviation in our actual data, then we would see a whisker plot like that example in the menu. Okay, so since that didn't help, I'm just going to change this back to markers that we can actually see. I'm going to go to, let's see, triangles. Why not? Okay. Great. You can change how many lines are here. You can change and add vertical lines if you like. There's all kinds of things you can do, and you can play with that on your own if you like. We can fit here. We're going to need a linear curve, a linear line that this data fits. And so here I'm going to select, again, left clicking or control clicking. I'm going to add a trend line. Okay, so if I add a trend line, you want to make sure that it's a linear trend line. Most of the data that you take in this class should be linear. Scientists in general really like linear data because we can fit it really well. We know how to fit it, and so you shouldn't be using these other types of fits at this point. You could here choose to display the equation of that line on the chart and display also the r-squared value on the chart. The r-squared value tells you something about how well your data fits that line. And so if you've got data points well above and below that line, then you're going to have a low r-squared that's away from 1. And if your data actually fits directly on that line, then that will be exactly 1. So you can see here we've got a pretty large slope, and that's because our x-axis is super tiny units. That's nice because we don't have to worry about sig figs in that case. If we're trying to use that equation some other time and the slope is super tiny, 0.00004 or something like that, it will not show you what the slope is in scientific notation, and so you usually only get one sig fig or maybe 2, which can actually introduce a lot of error when you're doing your calculations. So we're going to move on to the next item on this list now. 23 minutes. Where are we at? We're at about 24 minutes. Okay. We're going to talk about LINEST. So Excel just made this line for you. It's the best fit trend line to your data. How it did that is a process called linear regression. And you may not ever need to actually use this function, but it's super handy. And so I'm just going to show you how to do this. So we've got LINEST function here. In order to do the LINEST, actually have Excel calculate the parameters for this line, but also give you some error values for the slope and for the intercept. You're going to be referencing your data up here, and I'm going to select a set of cells, 6 cells, 2 by 3 set of cells, and I'm going to, while that whole selection is selected, I have to type in my equation. So I've got LINEST, okay, is what I want there, and then it asks for known y values and then known x values, and then some constant, and then stats. So we're going to select our known y values, which are going to be the average absorbance, right? That was our y-axis. So I'm going to select that now, okay? And then I'm going to hit a comma, okay? And now it's going to ask for the known x's. So I'm going to select the concentrations. I know what those x values are. And then you don't really need to know much about this. You just need to make sure that you type in true, comma, true. Close the parentheses and do not hit enter. Okay, you want to hit Command Shift Enter. Okay, so it's or Control Shift Enter. So I'm going to hit, there we go. Okay, so it's a 3-button click. If you just hit enter once, it'll just give you this slope number, and that's all that will give you. So this table that it's given you here, now this is the slope. Okay. This is the standard deviation of the slope, so you actually have an error value for that. This next number here is the r-squared value. Okay. This value is the intercept. Okay. Then the next value underneath it is the error in the intercept, or rather the standard deviation of the intercept. Okay, and then this value you don't really need to know. It's not going to be useful for you at all, so we'll just leave that out for now. Now for me, I'm going to just format this a little bit. Okay, this R2, it's not R2, it's R squared. Okay, so again, I'm going to go to Format, Cells, and I'm going to superscript that 2 so that I have an R squared. Okay, now what is this good for? Because you already have that information over here on your plot, right? But we need to use this information. We need to take our y values from our samples and plug them into this equation and solve for x, because we want to get, I have an absorbance value, what is the concentration, right? If you want to type all those numbers out, that's fine. You can do that. You can do it multiple times if you like. But now here I have some cells out here that have those numbers in them, okay, specifically these 2 numbers right here, that I can reference in a calculation. So over here I'm going to calculate the concentration of my sample, okay, and I'm going to do it for each trial, and then I'm going to average after that. Okay, so I've got my sample, I've got T1, I'm going to do a T2 and a T3. You'll notice right here I'm going to do that copy trick. Okay, so I'm going to go to black plus, I'm going to copy that over, and look, it changed my numbering there. So I didn't even have to change trial 1, trial 2, trial 3. Okay. So if I'm going to rearrange this y equals mx plus b equation to solve for x, I have to have the y value. So I've got my equals, my y value, minus, okay, I'm going to have to subtract and pull this intercept over here, right? So minus my intercept, okay? And then that whole quantity, which now I'm going to put in parentheses, because it's that whole quantity, divided by the slope, okay? So hopefully that calculation makes sense to you. I'm just rearranging the y equals mx plus b equation to solve for x, so you can prove that to yourself. Okay, so now it gives me an answer. It's in the right order of magnitude based on what I would expect, right? So an absorbance of 0.67 would be like here-ish, and I'd go over and I'd say, okay, that's about 0.4 something. Yeah, it's great. Okay, I'm going to change my decimal places to make sure I have a reasonable number of decimal places. And now I can copy that down. Okay, now let's just double check here. I've got a 0.4. So if I go to 0.4, I'm expecting a 2 times 10 to the 5th. And that's not what it gave me. Okay, so let's just consider here what we've got. Here's my equation. I'm referencing trial 1 of sample 1, and I'm referencing the slope and the intercept. Great. Okay. If I go to the second one, Oh, okay. So again, I'm referencing trial 1 of sample 2, okay? But I am no longer referencing the slope and the intercept, okay? So at this point, I'm in the equation. It's already typed. I'm referencing these cells. I can move this reference. Again, with my hand, I can move that up, okay? Over here, I can move this one up. And now it will be referencing the appropriate thing. But you'll notice now I have the same problem here. So the copying trick isn't going to help me very much if I have to move all these cells all the time. Okay. So what do we do about that? Well, we go back to our original equation and we say, okay, as I copy this down, I'm definitely going to want this reference to move down. Okay, but I don't want these references to move at all. Okay, and so to fix those, it's the purple one and the green one. Okay, I'm going to add a $ in front of D and in front of 28. I'm going to add a $ in front of C and a $ in front of 28. And what that tells Excel is fix that. Keep D constant, keep 28 constant. Keep C constant, keep 28 constant. And so now, when I copy that equation down, right, now we can see here that those references have remained constant. And these references have remained constant as well, but I'm only changing which sample I'm doing in that trial. And now that that's fixed, I can drag this over, copy over to the next two, and let's look at where they are. Okay, so now I'm doing trial 2 of sample 2, and I'm still referencing the slope and the intercept. So I can copy down and I can copy over, and those two references will remain static. Okay, this is super handy when you've got, you know, like do a bunch of calculations at a certain temperature and then change the temperature and see what happens. You can just keep the temperature in a different box, reference that, change that reference. So the $ is what I'm getting at, is that that's going to be super helpful. Okay, so now I have all the trials, their absorbance values have been turned into concentrations. And so now I'm going to put an average concentration, okay, over all trials. Okay, so I'm going to say average these trials. And again, I can just copy this down. Nothing needs to be static in this case. I've got an average. I can do a standard deviation, okay, of my 3 trials, sample 1 and of sample 2. Need to move my plot over, okay, just like that. All right. I'll want to change my decimal places here. Okay, great. So now I've got an average concentration for each sample. I've got a standard deviation for each sample, and we're good to go. So I passed my marker on this. I'm not really sure how long that took. Right now we're going to finish up with adding a data set to a plot. Okay, so here I want to put my sample data on here so that I can see where it lies on the line. And it should lie exactly on the line because we use the line to calculate the average concentration. Okay, so I'm going to do this thing where I left click or control click on my plot. I'm going to select data, okay, and that's going to bring up my window again where I can add series, change series, okay. So this series that's already on the plot, I'm going to call this my calibration data, and I'm going to add a new set of data that I'm going to call samples. Okay. I'm going to choose my X values and I'm going to choose my Y values. And so I want, on the X axis, I want the concentration, okay? And on the Y axis, I'm going to want the absorbance values. Oh, I didn't do it. Average absorbance. Okay, I'll select this for now. Okay. Okay. And now you can see these red squares, the pink squares, are my samples. So I can see the sample. I can add a standard deviation if I like. Okay. Let's see. Format data series. Error bars. I want Y error bars. Okay, I'm going to go to custom and specify my own values. My positive error bars are going to be, oh, cancel. These error bars that I have are X error bars, right? They're concentration error bars. So I'm going to go to custom, specify, and I want to choose my plus and minus from my standard deviation on my actual chart. Okay. Okay. And then this, I can just delete that because that's meaningless. Now, my standard deviations are pretty small, so again, I can't see them on this plot. I'll see if there's anything we can do by changing the marker style so that we can see what's happening. So you can kind of see that they have different lengths there happening, and that's because of the error bars. This data just doesn't have a lot of error in it. Alright, so hopefully that helps just in some of the basics, calculations, labeling, sig figs, scientific notation, etc. If you have any questions, ask your TAs. I'm sure they'd be happy to help you with any of this.